Hello viewers, in today's class we are going to discuss one very interesting indefinite integral, right? So here we have to evaluate this integral, and if we look at this integral, then the problem seems a little bit difficult, right? But here the problem will be reduced to an easy one by making use of one important result from logarithms, right? So let us start. Now here let us first denote this integral by I, right? Now here we see that we have three terms, that is this one is first, second, third, and then we have x in the denominator, right? And we have to find the value of this indefinite integral. Now here what we will do, we'll first make use of an important result from logarithms, that is the base changing formula, right? So the base changing formula, it goes like this. If we have say a log of a b, right? So here the base of the logarithm is a, and here we have to find the log of b when the base is a, right? Now see, here the base is a, and suppose we wish to change it to the base e, right? So e is the exponential number, right? So now here what we will do, we'll change this base a to e, right? So for this what we will do, we'll write log, then we'll write simply log b over log a, right? Log b over log a, and here we'll put the base e, right? So this is how we can frame the base changing formula, right? So I am once again repeating. See, if we have say log of say n to the base m, now we want to change it to the base e, right? We want to change this base m to e. So what we will do, we'll write simply log n, then divided by log m, and we'll put here the base e, right? Okay, so now here we have to make use of this base changing formula to first simplify these three terms. Now let us first take this term, right? So we have log of e, and the base is ex, right? So now if we make use of this result, then if we compare, then we have a is equal to ex, right? And b is e, right? Okay, now we want to change this base ex to e, right? So what we will do, we'll simply write log e over log ex, and then we'll simply put here the base e, right? So this is how log of e to the base ex can be written like this. Now let us take the second term. So here we have log of e, and the base is e square x, right? Now again, if we compare this term with this one, then we have a is equal to e square x, and b is equal to e, right? So now we can change this base e square x to e by simply writing, first we'll write log e, then we'll write log of e square x, and then we'll simply put here the base e, right? Now similarly we can take the third term. So here we have log of e, and the base is e cube x, right? Now again, if we compare this term with this one, then the value of a is e cube x, and b is equal to e, right? So now this term can be written as log of e, then log of e cube x, right? And we'll simply put here the base e, right? So viewers, these three terms would be written like this with the help of the base changing formula, right? Okay, so now here we'll further simplify these three terms, and here if we observe that in the numerator we have log of e to the base e, right? So we know that the value of log of e to the base e is simply 1. So here we have 1 over log e ex, and here also log of e to the base e, so we have 1. The value of log e to the base e is 1, so we have log of e and e square x, right? Similarly, here we have the value of log e to the base e is 1, and we have log of base e, and here we have e cube x, right? So now we have simplified these three terms to these terms, right? So now let us apply one more important property of log, right? So we know that log of AB, right? If we have the product of the log of the product of two numbers, then we have log of A plus log of B, right? So now here we see that in the denominator we have log of ex, that is a into b, then we have log of e square x, this is a, this is b, and here we have log of e cube x, this is a, this is b. So we'll apply this rule, and moreover we'll require one more result from logarithms, which says that log of say m raised to n is n log m, right? Okay, so now let us simplify these terms further. So now we have 1 over log e plus log of base e x, right? So here we have applied this rule, log of ab is equal to log of a plus log of b, right? Okay, now let us come to this term. So here we have the base e, so we'll take it as such. So log of e, then this is a, this is b, so here we have log of e square plus log of x, right? And here we have 1 over log of base e, and then we have e cube, because this is a, this is b, and then we have log of e, and here we have x, right? So this is how we have simplified these three terms, right? Okay, so now viewers, again we see that here we have log of e to the base e, and that is equal to 1. So we can now write 1 over 1 plus log of x to the base e, and here we have log of e square. So if we apply this rule to this term, then what we will have, we'll have 2 times of log e, and log of e to the base e is 1, so we have 2 times 1 is equal to 2. So the value of log e square to the base e is 2. So here we can write 2 plus log of x to the base e, right? Okay, now let us come to this one. So here we have log e cube to the base e. So again here we can apply this rule. So we have this power 3, which can be taken in front of log e to the base e, and log of e to the base e is 3. So we have 3 times 1, that is 3, right? So now we can write here 3 plus log of x to the base e, right? So I hope uh, this is clear to you, and now let us move further. So now viewers, here since we are writing the base as e, so now it is quite evident that the base e is involved in these three terms. So we can omit this e for just simplicity. So we can write 1 plus simply log x, right? Because it is understood that here we are using the base e, right? So this term can be written as 1 over 1 plus log x, right? Similarly, this term can be written as 1 over 2 plus log of x, and this term can be written as 1 over 3 plus log x, right? So here it is understood that the base is e, right? So now once we have expressed these three terms like this, now let us substitute these values over here, right? So now our integral I, it takes the form 1 over 1 plus log x for this term. Then we have 1 over 1 plus here we'll have 2 plus log x, and then we have 1 over 3 plus log x, and here we have dx over x, right? So here's this is how we see that how we can simplify the integrand in this way, right? Okay, so now we have here 4 terms, and we have to evaluate this integral. Now here we clearly see that we have a term like 1 over x here. So now if we make use of the method of substitution, then we can put t is equal to log of x, right? So we'll make the substitution, t is equal to log x. So therefore dt over dx is equal to 1 over x, and dt can be written as dx over x, right? So now here we can write dt, and now our integral, it takes the form 1 plus t, because log x is t, then we have 2 plus t, and then we have 3 plus t, right? And here we'll have dt, right? So now this integral reduces to this one. So now viewers, we see that we arrived at a form where we have to use the method of partial fractions. So now we have our integrand like this: 1 plus t, 2 plus t, and 3 plus t, right? And we see that here we have 3 linear factors, right? Linear factors. So now we can write, or we can decompose this rational function into 3 partial fractions, like a over 1 plus t, then we have b over 2 plus t, and then we have c over 3 plus t, right? And now we can take the LCM, and we have 1 plus t, then we have 2 plus t, and 3 plus t, and here we have a times 2 plus t, 3 plus t, then we have b times 1 plus t, and 3 plus t, and then we have plus c, and we have 1 plus t times 2 plus t, right? Okay, so now if we compare these two sides, then we can write 1 is equal to a times 2 plus t, then 3 plus t, then we have b times 1 plus t, 3 plus t, and c times 1 plus t and 2 plus t, right? And now here our aim is to find out the values of the constants a, b and c, and we already know that how to find the values of these constants. So we'll assign some values to the variable t, and we'll neutralize two terms, and then we can find out the constant from the third term, right? So here let us first take t is equal to say minus 1, right? So here we have 1, and when we take t is equal to minus 1, here we have a 2 minus 1, then we have 3 minus 1, and this term becomes 0 because this is 1 plus t, and t is minus 1, so 1 minus 1 is 0. Here also this term becomes 0, and now we have 1 is equal to a times 1 times 2, and a is equal to half, right? And now let us take t is equal to minus 2. So when we take t is equal to minus 2, then this term becomes 0, and then we have here b times 1 minus 2 and 3 minus 2, and here this term becomes 0 because t is equal to minus 2. So here we have 0. So now we have 1 is equal to b times 1 minus 2 is minus 1, and 3 minus 2 is 1, right? And simplifying this one, we have b is equal to minus 1, right? So a is half, b is minus 1. Now we have to find the value of c. So now let us take t is equal to say minus 3, right? So when t is minus 3, then this term is 0, and this term also 0. Then here we have c, and 1 minus 3 and 2 minus 3, right? So we have 1 is equal to c times minus 2, 1 minus 3, 2 minus 3 is minus 1, and so therefore here we have minus minus plus, so we have 2c, and c is equal to half, right? So viewers, here we have obtained the values of the constants a, b and c. So now viewers, our integral I can now be written as see 1 over 1 plus t, 2 plus t and 3 plus t. This integrand is now expressed like this. So we have a over 1 plus t, then p over 2 plus t, and c over 3 plus t, right? And here we have dt, and now we have just obtained these values. So now we can substitute them here, and we have this expression, and we can now integrate, or we can find out the value of this integral very easily, right? So now here we'll make use of an important result from integration, that is dx over x plus a is equal to the integral of 1 over x plus a is a log of x plus a, right? So here we have half, and integral of 1 over 1 plus t, then we have minus dt over 2 plus t, and then we have half, and integral of dt over 3 plus t, right? And here we can write k as some constant of integration, right? So now here we have half, and integral of 1 over 1 plus t is log of 1 plus t, and then we have minus, and here we have log of 2 plus t, the integral of 1 over 2 plus t, and then we have plus half and log of 3 plus t, and k is the constant of integration, right? So now in order to get the final result, here we can replace t by log x. So we have the final result as half log 1 plus log x. Then we have minus log of 2 plus log x, and then we have plus half log of 3 plus log x, and k is the constant of integration, right? So viewers, this is the final result, and we can also simplify it further by making use of the properties of logarithms, right? But we'll accept this result, and this is how we solve this indefinite integral.